Hey Geometry, this section is entitled Measuring Segments. We're going to start out here, as we always do, with our vocabulary. The first phrase, not necessarily word, but phrase we see is congruent segments. What are congruent segments? Well, congruent segments are segments of equal length. Now, we don't have to know necessarily the number value or exactly how many units long the segments are. We just have to know that the two have the same measurement. So, congruent segments. The next word is midpoint. Well, what is a midpoint? A midpoint is the point halfway between 2 points, splitting the segment into two congruent segments. So that's the main thing here, is that we see that it splits the segment into two congruent segments. So if we had one point here, we'll call that A, and we had another point here, and we have segment AB, if C was the midpoint, it'd be directly in between. Okay. Now what you're going to see throughout the year is that there's going to be marks like this. What those marks mean is that these two segments, segment AC and CB, are congruent to each other. So if you see these two marks, that would also imply that C is the midpoint. Okay? Alright, now how do you find the distance between 2 points on a number line? Well, yes, there's the easy way if the numbers are close on a number line of just counting from one point to the next, but is there a specific formula that you can use just in case the points are very far from each other? And of course there is. So the formula to find the distance between 2 points on a number line, what it is, the absolute value of 1 point minus the other. Okay, 1 point minus the other. So now you can choose either point to start with. You just have to make sure after you subtract you take the absolute value. So these two are the way to find the distance between any 2 points on a number line. Okay? So let's do that. Find the distance of AB and BC. Are the segments congruent? Like I said before, yes, we can just count over 1, 2, 3. So we see that AB is 3 units, and BC here, 1, 2, 3, is 3 units. But just to prove that the formula works, let's apply those. So I'm going to do AB in yellow here. So what you would do is you would choose 1 point. I'm going to choose B first. -5 minus the other coordinate, which is -8. Okay, the other point. Here we've learned a long time ago that two negatives next to each other becomes a plus. So you have the absolute value of -5 plus 8. Sorry for the handwriting here. And then that means the absolute value of 3, which is 3. Okay, just like we counted over. Now the other one, C, we have -2, which is C, minus B, which is -5. You can take the absolute value, so those become pluses. So again, we have the absolute value of 3, which is 3. Okay, so these segments are congruent. Now the way we would write that, well, we'll get to that next actually. So yes, counting is much simpler when it's like this, but what if, it's good to know the formula, because what if A was at -49 and B was at +62, and you had to find the distance between the two? You wouldn't want to count that many one by one. You could just apply this formula and you can come up with the answer much quicker. So that's the advantage of knowing how to find the coordinates using the absolute value formula here. Okay? Now, like I was hinted at a second ago, as I said, we were going to write that the segments are congruent. Well, what is the difference between equal and congruent? Well, it's all about notation. If we actually know the specific number value, we can say that two segments are equal. Now, labeling is very important. So I'm going to do, the left side, I'll go ahead and do in yellow. Notice that it says AB is 2 centimeters and CD is 2 centimeters. So what we can do is we can say the length of AB is equal to the length of CD. Now you have to be very careful on how you write that, because on this side, on the right side here, it doesn't tell us number values, but it does give us markings. Here on AB it has 2 marks and CD has 2 marks. So that what it's saying is that they're congruent to each other. So the way we would write that is we would say segment AB with the segment over it is congruent to segment CD. Okay. Please notice the difference here. When we're saying the length, notice there's no, we put nothing above the letters AB. And we use an equal sign. So basically what we're saying with the yellow one is that the length of AB is equal to the length of CD. Whereas the other one says AB, segment AB is congruent to segment CD. Again, this one we know their number values. We know the number values on this one. On AB and CD, we do not know specifically how long they are. We just know that their distance are the same as each other's. Okay? So again, it's very important we make sure we know how to use proper notation. To say their number values, we use no segment above. When we don't know, we do use the segment above when we say congruent. Okay? I know that can be confusing, but we got to get used to labeling this correctly. Alright. Now, here we have a thing called the segment addition postulate. Now, what this is saying, and it's pretty much basic sense, but we still have to go over it. It says the segment AB, that distance right there, if we were to add that to BC, then we would get the entire distance, which it is a pretty basic postulate, but we're still going to have to work with it with variables and whatnot. So again, length of the small segment AB plus the length of the small segment BC is equal to the entire segment A to C. Okay, that's the segment addition postulate. So now let's put that into play. Here it says if dt, and notice again there's no segment sign above dt because we are talking about the actual number value. The length of dt is 60. So therefore this whole length is 60. We need to find the value of x. Then find ds and st. So we use the segment addition postulate. So we can say ds plus st is equal to dt. So the first half, or first not half, or first part is ds, the second part is st, and it adds up to the entire dt. Here what we do is called substitution. We're going to substitute these values in now. So instead of saying ds, we could say 2x, write that a little better here, 2x minus 8 plus st, which is 3x minus 12, is equal to dt, which in this case it tells us is 60. Okay? Again, 2x minus 8, which is ds, plus 3x minus 12, which is st, is equal to 60, which is dt. Well, from here we can just combine like terms. So we have 2x plus 3x is 5x. Negative 8 minus 12 more is negative 20. And that's equal to 60. And here's just, again, regular algebra steps from this point on. So we're going to add 20 to both sides. To get x by itself, you want to isolate the variable. So we have 5x is equal to 80. And our last step there is to divide by 5. Okay? So we have x is equal to 16. Now, whenever you think you're done with the problem, what you should always do is go back and read the directions and see if you've solved for everything it asks. Because it does ask us to find, or it tells us to find, the value of x. X is 16, but notice we still have to do two more things. Find the length of ds and the length of st. Well, ds is 2 times whatever x is. In this case, we found that at 16. So ds is equal to, that gives us 32 minus 8, which is 24. Now if that's true, then we should get 36 for st, because notice we have 60 here, for the entire thing. Minus 24 gives us 36. But we always want to check our work by plugging in. So we have ST is equal to 3 times 16 minus 12. Okay, so finally ST is equal to 48 minus 12, which is 36. So we know we did it correctly. There you go. There goes our answers, okay? So again, segment addition, one segment plus the next, if they're in a straight line or straight segment, equals the entire segment. Okay, let's get to our last problem here. C is the midpoint of AB. Find AC, CB, and AB. Now notice it gives us no specific numbers for an entire section. But the key word here, is midpoint. Again, a midpoint is directly halfway between two other points. So what does that mean? It means that the length of AC is equal to the length of CB, because C is a midpoint. Again, from here we can just substitute those values in. So AC is 2x plus 1. CB is 3x minus 4. So this is how you can handle problems when you see especially that keyword midpoint. Let's do some regular algebra steps here. We're going to subtract 2x. We want to get the variables to one side. So that gives us 1 is equal to 1x minus 4. And we're going to add the 4 over to get x by itself. Okay? So we have 5 is equal to x. Okay, x is equal to 5. And again, that's actually not even what it's asking us to find for our final answer. Notice nowhere in the direction it says solve for x. Now we had to solve for x in order to find what we're looking for. It says AC, CB, and AB. We have to find all three of those. Well, now we know x is equal to 5. So AC, 2 times 5 plus 1. That gives us 10 plus 1, which is 11. 3 times 5 minus 4. Now again, we said they're equal, so this should equal 11. That's 15 minus 4, which is 11. So we know we did it correctly. It's a great way of checking your work. And lastly, it says AB. Well, if the first half is 11, the second half is 11, the total would be 22. So those would be our answers right there. Okay? So again, key with the midpoint is you set the two sides equal to each other and then solve for the variable. And if you have to plug in to find more information, that's what you do. So that is how we find the measurements of segments. Okay? So good luck. Again, keys are midpoint and segment addition. Okay? So good luck with that lesson.